Hi, in this video we're going to be looking at number 55, problem C. So we're looking at tangent line having a specified slope. We had this curve. If you recall, in my previous videos we were looking at this curve here, y equals x cubed minus 4x plus 1. This was our curve, and in this problem we're looking at this curve such that the slope of any tangent lines to it is 8. It says find equations for the tangent lines to the curve at the points where the slope of the curve is 8. So we're going to find all the slopes that have slope of 8 of this curve. So let's go ahead and into MATLAB. I've already put in the problem and the graph of it. This is the graph and the problem, and I've already taken the derivative here, and we have m equals 8. That's the slope. So if I go ahead and run this, I get this graph here. This is a good graph, but we're interested in a different span. We're going to look at specifically from -3 to 3 and -6 to 6. So we have a better view because all the action is happening in that range. So what I'm going to do is I'm going to say axis. So axis, and we're going to put in -3 to 3 and -6 to 6. And if I run this again now, so I get a better graph. It's because the slope is actually happening in here. So these two, because it's symmetrical, it's a symmetrical sort of graph. So the two lines that have slope of 8 are gonna be going. They have a positive slope. They're happening along this part of the curve. So what I can do here, I can copy this figure and let's go over to OneNote and paste it. So let's make this a little bigger maybe. Let's see. All right. So what we're interested in is these two lines here that have the slope of 8. They happen along the curve somewhere around here. Somewhere, maybe a point there. Maybe it's not at 0. We don't know what that is. That's our goal will be to find these two lines, those tangent lines that have the slope of 8. So it looks like something like this, and somewhere along, maybe it's here, somewhere along the curve, there is a point such that at that point the equation of the tangent line have the slope of 8. So let's go ahead and back into MATLAB and find what that is. Okay. So let's go into our solution section, and what I'm going to do is I'm going to invent an equation and set it equal to m. So I'm going to say equation 1 equals dy equals m. So I'm going to set dy equal to m. This is how I get my x solutions. So next I'm going to say x sols. This equals solve eq1. Okay, so these are the x solutions. This is basically the x-intercept of this equation here, the zeros of this equation, dy equals m. But we also need the y coordinate points, the y coordinates of that point. So what I'm gonna do is I'm gonna do it through a for loop, since we need to find all the points such that the tangent line has slope of 8. So what I'm gonna do is I'm gonna say for k equals 1 to length x sols, yeah, like that. So for that range I'm gonna do y sols equals subs, and we have y, x sols, and k. So this finds all the y coordinates of the points that we are interested in, such that the slope will be 8. So then line equals m times x minus x sols k plus y sols. So let's say plus y sols, like that. All right. So I can also plot the points in the for loop. So we plot all the points that we that gives us that slope. So we can say plot, and x sols k. Okay, and then let's see. We can also plot y sols, obviously. Y sols, and we're gonna plot it with a dot. So let's do a dot like that, and the color. Let's make it red. Let's make it actually black. So we're gonna say black, and marker size. Let's do marker size 18. All right, and then we're gonna plot more stuff. So we're gonna say hold on, and we're gonna plot. So G now equals f plot the line like that, and we're gonna set. I'm just gonna copy and paste here. So color, make it red here. So this is, oops. So set G, and color will be red. Line style will be style dash. So we're gonna put a dash in there. All right, and hold on still because we're adding more to our graph. All right, so that's the for loop. So that's the end of the for loop there. Actually, we don't need this hold on. Maybe just say hold off, because I think that's all we need to graph here for this problem. So what I need to do now is just add the legend and x label, y label. So x label, just call it x, and y label y. And I'm gonna add a fancier legend. So because our legend will not be in order, so we're gonna call the Q, and just like this. And then also G, and like that. And let's come out, and so the first one will be curve, and the second one will be lines with slope of 8. Lines with slope of 8. So that's the two things we're interested in here. Oops, that should be like that. All right. All right, I fixed my code. I had some errors. So for the legend, I'm interested in graphing f. F is a function up here, the y function, the curve, and G would be the line. Otherwise, it would go in order, and it would, in the legend, we would be having plot the point. And we're not interested in the point. We're interested in legend specifying the line and the curve. Those two only. So when I run this, I get this nice graph. So that we can make this bigger, and these are the two lines where that happens. The slope is 8 in this case. So the first line happens at that point, and the second line with slope of 8 happens on the opposite end of it. Notice this is a symmetric graph. So this is -2 in a y coordinate, and +2 in the same y coordinates. All right, so that's how we find this. That's how we solve this specific problem. Thanks for watching.